Okay, so we're going to solve by graphing. Now, we have three methods to solve. Oh, I told you that before, but we actually have lots of methods to solve. We're going to go over, though, in this section, three methods of solving a system of equations, linear equations. And the first method we're going to look at is graphing. All right, so solve the system of equations by graphing. Identify the type of system. What that means is they just want to know, is it independent, inconsistent, or dependent? Those are your choices. So we'll do that at the end. Dependent. Okay. So first we're going to solve. I'm going to take the top equation. I'm going to write it in orange. I have 2x plus y equals -8. Now, you could go ahead and make a table of values. That's one way you could do it. You could use the intercept method. I'm going to go ahead and write it, though, in slope-intercept form and use the slope y-intercept to graph it. So it's been maybe a little while since we've done graphing, but this is the slope and this is the y-intercept. So y-intercept at -8, and then the slope is -2/1. Now I'm kind of out of room. I'd like some more points so I can go up 2 and back 1. And I'm getting this equation to graph like that, something like that. Probably should have gone through this point here, but okay. Now I'm going to graph the other line. I'll do it in green, this line. So x minus y equals -1. What I can do to put it in slope-intercept form, like I did on the last one, move the x over, and then I'll just divide everything by -1. So I get y equals x plus 1. Okay, so my intercept is at 1, and then I've got a slope of 1. And so it's going like this. Okay, so we've graphed both lines. To solve it, we need to find the point of intersection, which looks like about there, right? So it looks like it's at -1, 2, 3, -2. I'll say -3, -2. That works, that's the point. Now I could check it and see if I'm right. I could say, does it work in this equation? So 2 times -3 minus 2, does that equal -8? And in fact it does. So yeah, it works for that one. And let's see if it works in the other equation. So we would have -3 minus -2, does that equal -1? -3 plus 2, does that equal -1? Yes. Okay, so our solution actually works. When you're solving by graphing, for an exam, you don't necessarily have to check it unless it says to. Okay, so let's answer the question. Was it independent, inconsistent, or dependent? When it's inconsistent, that's when the lines are going to be parallel. When it's dependent, that's when it's just one line. So this is an independent system. Now, the problem with the graphing method, it hopefully makes sense, and it worked really good on this problem. The thing is, it can be really inaccurate. You know, if your lines are off, it's going to be hard to tell where the point is. And what if the answer is like a fraction, like 16/17? That would be really hard to read off a graph, you know. So the graphing method's great. It gives you a picture of what's going on. But there may be some problems with accuracy when you're using that method. And that's why we have two other methods that are much more accurate.